So we looked at 2 lectures ago, quantitative methods. That's a very short introduction to the topic. As we know, you can take a whole module about quantitative methods. It's called statistics. You can take a whole module on visualization. You can take multiple modules on these topics, actually. Where you can take a module on qualitative methods too. It won't be that exciting, but you could take them. We're just going to give a brief introduction to qualitative methods. So there's this. It's easy to mix these up, by the way, quant and qual. Like quant refers to quantities or numbers. Qual refers to a description of things that can be observed but not measured. Usually qualitative refers to natural language texts. It's very common. So quantity is numbers, quality or quantitative. Qualitative refers to natural language, usually, not always, usually. But when you see the word qualitative, think natural language and that will help. Yeah. And there are so-called mixed methods that use both, incorporate both qualitative and quantitative. So we can think about how we obtain knowledge. And we have to be careful about this word knowledge. It's very abstract, isn't it? Knowledge. There's a sort of pyramid or hierarchy, knowledge hierarchy. I don't know if anybody's ever looked at that, but at the bottom of the hierarchy is data. Then above that is information, and then above that is knowledge. Anybody knows what goes above knowledge? Wisdom. That's the highest. Anyways, where the distinctions are between those things is not 100% agreed upon and clear. So how do we increase our knowledge of the world, right? This is what we're really asking. We conduct experiments, we make observations, we talk to people, we conduct simulations, we analyze documentation and images, right? We might have a mathematical proof and thinking, like thought experiments, right? Or making new things. There's this idea of the philosophy of knowledge defined as justified true belief. We have to believe something in order to know it, but we might have some probability associated with that belief. Usually there is a probability associated with believing things, like I'm 90% sure. Usually there's some probability. It has to be true. You know, these are very philosophical words, aren't they? Like, what is truth, right? For me, when I see this word true, what is true, I think reproducibility, actually. Like if somebody tells me something, there has to be a way to reproduce that, right? And re-observe it, observe it again, right? It has to be repeatable. It should be justified. We have to explain how we came to that knowledge, otherwise it would just be a coincidence, right? That's inherently tied to the repeatable and reobservable replicability characteristic. Right? It has to be reproducible. Say that 10 times fast. Here's a kind of overview of methods, quantitative methods and qualitative methods. So remember, quantitative is dealing with numbers, measurements of physical properties in different situations. It could be observational. So we could count things, like we could just sit in a chair and like count things, like the number of people walking by. You know, that could be an experiment. We can do things with eye tracking. These are just 2 examples. Reports and reflections. We can conduct surveys, hand out questionnaires, and then try to quantify those. typically described using words. So that's what I often use the phrase natural language and natural language processing. But that's what I think of. Typically using words, right? Diagrams, pictures, actions. User studies, everybody knows there's a very active user study group here at the university, right? Human-computer interaction, ethnography, case studies, conversational analysis. Case studies, does anybody understand what a case study is? It's really an example, right? Collecting examples of something being applied in the real world, usually. And then we have things like interviews, thinking aloud protocols, focus groups, free questionnaires. These are some of the topics we're going to be talking about over the next days. And of course there are other ways, right? Mathematical proofs, simulation, and creating new things. So before we conduct any kind of user study, so this natural language and qualitative methods, I hope I don't confuse quantitative and qualitative. Qualitative methods usually involve people, right? And people usually communicate through natural language. Not the only way, but before conducting a study, we have to make sure we know what we're investigating. Do we have a clear question that we can formulate? Do we have a hypothesis? Or are we trying to get a broader overview of how people engage with a topic? It's good to have some hypothesis or some specific question you're trying to answer. But not all experiments have that in the beginning. Does anybody know what research is called if there's no specific question or hypothesis at the beginning? There's a word that's very popular to use in that case. It's called exploratory research. That's an advanced question. I wouldn't expect everybody to know that. But there are experiments that are conducted without any clear hypothesis or question. And that happens a lot in the arts and humanities. They do a lot. I've done some work with the arts and humanities, and I remember one of my colleagues describing some research they wanted to conduct. They gave me a description, and I said, what is your hypothesis? What is the question you're trying to answer? And they just looked at me and said, that's not how we think, Bob. It's like they don't articulate a specific hypothesis. Are you concerned with actions or inner behavior, the way people think? Do you want to know how a person will do something? Do you want to know what they are thinking, feeling, during, or what? Are you going to look for evidence in specific categories, or are you open to what people are going to say and then generalize it? And before you conduct a study, you always conduct a so-called pilot study, which means you test out your experiment a few times with some test people, and then you work out the problems. There's usually some problems, like some things that need to be fixed. And how are you going to get access to people? That's always a big question, like how are you going to recruit participants if you need participants in a study, right? Is the sample of people you're going to engage with a fair sample, right? So sometimes people will conduct a study and they say, we believe that people will perform this task faster or more quickly or more accurately under these settings. They run a study with their friends and they try to generalize it to the entire population on Earth. So that's a tricky business, right? So you want the people that you recruit for your study to be representable and generalizable. If we observe 30 people using a piece of software, do we think that these observations can be generalized, right? can we expand those observations to the greater population? And there's no exact number. This is a constant sort of discussion in the scientific community. How many participants do you need to generalize? And there's no, if you ask 100 scientists the answer, that you get 100 different answers. You know, it's really up to debate. How do you avoid unwanted biases in your sample? Right. Typically, the human-computer interaction studies here are just a bunch of computer scientist students, right? And do we actually represent a greater population, right? Human psychology is the study of undergraduate psychology students, right? The same thing can be said about computer science studies, right? They're typically other computer scientists participating. After you've gathered your so-called information, or you could probably data is a better word, how are you going to turn that knowledge into so-called findings, right? We can think of turning data into information, and from information into knowledge, right? You need to get your data and information into a usable form, right? If we're looking at natural language processing, right, we're talking to somebody, we need to get their words onto paper, so to speak, or transcribed. That's easier nowadays. That used to be done manually. Now it could be automatic. Usually the data is anonymized, so the person associated with that is they're anonymized, so we don't write down their names. And then we have to figure out, if we have interview data, how do we analyze interview data? Like, how can we organize it? How do we analyze it? One of the ways is so-called coding. And coding just means looking for themes that repeat over and over again. They're usually more abstract than the individual words themselves. Like, what is the subject that the person is talking about? Like, this person is making a statement about coursework 1, for example, or coursework 2, and then we can find all the places in an interview where somebody's talking about a specific subject. Right? That's what coding is. Also, important comments might not be frequent ones. So, for example, somebody might say something only once, and it might be important. So, that somebody has made a very unique observation, and they were the only ones to make it out of a sample size of 100 people, for example. But usually importance is connected to frequency, like how often something happens, usually, if you think about it. So if something happens thousands of times, it's important generally. If it happens millions of times, it's even more important. So we build up a so-called cognitive map of concepts that emerge in their connections, and then we start to look at those. Here's just some fun example. Why did you not take your medicine as the doctor requested you to? That could be a question in an interview, right? A common question in some medical setting. So there are different replies here, like, I forgot, I didn't like the taste, I forgot, I was too busy, I left the bottle at home, I forgot. So there are themes here, like the forgetfulness theme keeps reoccurring, right? I can count how often the forgetfulness theme comes up. 1, 2. This is like I forgot too, in some ways, arguably. So 1, 2, 3, 4, 5, 6. You know. So we can actually count how often, for example, this notion of forgot came up. I was too busy. That concept we can count as well. Too busy, 1. I only see it once actually. Oh yeah, I guess only once. Sleeping is only used once, and so on. And then there are 2 reasons that are sort of connected here, right? I thought I didn't need to take it anymore, right? That's connected. So we can look for common themes and count the number of times those themes are mentioned, right? And there are tools. I just did that sort of manually by looking and counting, but there are tools you can use to help analyze interviews and text. So you're reading the text and then you're trying to assign topics to the text, right? And then, so this is text, somebody has labeled this paragraph with a specific theme, right? And they've labeled it here, right? Code stripes. So this addresses one theme, this addresses the same theme, this addresses the same thing. Here's a different theme. So somewhere in the text has been labeled with a different theme, somewhere in the text has been labeled with infrastructure, and so on. Right, and there are all the different interviewees. So all the different interviews have been loaded into the software. The interviewees are labeled, and then they're going through reading and doing this so-called coding, right? That software is called In Vivo. Anybody ever used that before? Anyway, so a lot of time is spent doing things like that, right? Coding a natural language. So what are we looking for? We're looking for patterns, trends, and outliers, evidence that either supports our hypothesis or refutes the hypothesis, counter evidence, right? And we always have this concern about biases, right? If we're looking for something, the chances are greater that we're going to find it. But that's a kind of bias, isn't it? Because I already know what I want to find. So we're always thinking like, how do we make this as objective as possible and reduce the bias, right? Are we discovering a real pattern, or are we just artificially creating evidence that supports what we believe, right? And then we have these 2 kind of theoretical terms, inductive versus deductive research. So qualitative research is described as inductive. In other words, we start with the data, look for patterns, and then develop a theory. Whereas quantitative research is so-called deductive, right? We start with the theory, actually. Then we conduct an experiment, collect the data, and then see if the data supports our theory or counter or refutes our theory. Right? So this is a kind of schematic of the process. Inductive, we start with a specific observation. We look for patterns, and then we try to generalize the conclusion, right? That's the bottom-up approach, and then the top-down approach is we start with a theory, we formulate a hypothesis, we collect the data, we analyze the data, and then we either confirm or reject the hypothesis. So here, these 2 correspond with each other, and then these 2 correspond with each other, right? And then I would say something like maybe this one corresponds to these 2. It's almost like a flipped process. You can read more about that at the link. So some common generalizations. Remember, generalizations are not always true. So there are always exceptions. 5 common generalizations about quantitative and qualitative research. Quantitative research is objective, while qualitative research is subjective. So quantitative measures of physical quantities have a consistency and reliability that reports and reflections do not have. But that does not mean qualitative research is not very useful, and we can't derive new knowledge about the world from qualitative research. And quantitative research can also have bias because we have to choose what we want to measure. Somebody is deciding what to measure, and they're also deciding what not to measure, like what to ignore, like where to look and where not to look. Like one of my bachelor's degree is in physics, and I'll never forget the day that one of my experimental physics professors said, we conduct an experiment 999 times and it fails, and we don't talk about it. We conduct it the 1000th time, it works, then we write up the results and report it. Boom, right? It's a really funny observation. Qualitative research is about discovering ideas, whereas quantitative is about testing them. Right? So a common approach in qualitative research is grounded theory. So that's where you start with the data, right? And then given the data, you start to formulate hypotheses. So the data comes before the hypothesis, right? That's in grounded theory. You investigate a broad topic through interviews, focus groups, observations, and then form theories about your observations. Right? So that's often true about qualitative research. But that can also happen in quantitative research. You can conduct an experiment and then discover something new that you didn't expect, right? One of the first things that we need to decide is whether a study is qualitative or quantitative, right? That's usually true, but not always true. Sometimes we use a mixture of methods. In computer science, it's very common. It's really common to use both qualitative and quantitative methods. In visualization, we generally use both. So we could have questionnaire with some numerical scores and some free text answers. Sometimes an experiment will start out qualitative and then turn quantitative and vice versa. Like there might be 2 parts of an experiment. I'm just trying to finish before we run out of time. Quantitative research is about making measurements of what is happening, whereas qualitative research is about asking people's thoughts and opinions. That's generally true. Not always true, but generally true. Sometimes good qualitative research can begin by asking people to talk carefully through what they are doing and contextualize it, and then draw findings from this description. Does anybody know what that's called? Asking people to talk carefully through what they are doing. Anybody know what that's called? That has a name in research methods. The think aloud protocol. Like think out loud, like tell me what you're thinking. What has your experience been like of interactions between UK and overseas students? Right? We could give you a questionnaire, right? A scale of 1 to 10 or 1 to 7 versus what do you think of relations between UK and overseas students versus next week keep a careful diary of the interactions that you have during your studies and summarize the topics of conversations that you have and with whom. These are 3 different ways of trying to solicit similar information, right? One's using a questionnaire, one's using an open-ended question, and one is using a diary. So 3 different qualitative methods for trying to study the same theory, right, or support the same theory, or study the same subject. Quantitative research is driven by theories, whereas qualitative research is driven by stories. But there are theories in qualitative research too. Some of these exist prior to the study, and some emerge during the study. In my experience, everybody has a theory before they conduct a study. Like, there's some, at least in my experience, if it's qualitative or quantitative, there's always a theory beforehand. And the theories are usually the driving force behind the studies. Like, I think this, I believe this, and therefore I'm going to try to figure out how to accumulate evidence to support my belief. That's usually how it works for both quantitative and qualitative, usually. And quantitative research can have stories and expectations behind it. Sometimes we need an odd quantitative measurement, but then we need to come up with a story to explain it, right? And that can lead to new theories, right? Like discovery of microwave background radiation, right? That was discovered by accident. Here's a bonus generalization from my own, just my own observations. Quantitative research studies numerical data, whilst qualitative research studies natural language data. That's my own kind of lens on how I see this. It's a generalization. And so if you look at the world through that lens, what you see, you get a slightly different picture, because numerical data, I would argue, is more certain. You could say, like, a number is certain. Numbers have probabilities associated with them too, by the way. They have error and uncertainty. But if you look at text and natural language data, that has, generally speaking, more uncertainty in it. So if you look at words and you consider them through the lens as data, that's data, but the level of uncertainty associated with that data is probably higher than with natural language processing. Right? I can say something to you using natural language, and I can say it 10 different ways. So there's uncertainty, and it's very easy to misinterpret somebody's words, right? You don't need me to convince you about that, right? How often have you gotten a text and you misinterpret that text, or an email, right? Happens a lot. And some, actually, I read an article, and I still have the article, by the way, that says more than 50% of all email and texts are misinterpreted, which is a huge number. There's a lot of uncertainty associated with natural language data. And we can try to make conversions between numerical and natural language data. Okay, so that's the short introduction to qualitative and quantitative research. If we had time, I was going to start the interviews, talking about interviews today, but we don't have time, which is okay. Any questions about our introduction to qualitative research methods? We're obviously going to be talking about them more in the next week's question.
The number of people for the research. I remember one of the statistics is a way to find out how many samples you want to get really complicated. Why is not?
Yes, there are tools. So if I understood your question is about how to decide how many people to recruit for a given study. There are guidelines and tools for this. One of them is called a power analysis. So if you Google like power analysis for user studies, it's a kind of tool that offers a formula for how many participants you need. As a general rule of thumb, the more participants you have, the more accurate your experiment is going to be in the end. Another way of saying that is the more participants you have, the more confident you can be that your results are good, basically. It's like one fun experiment. A fun experiment is, to set up an experiment, conduct it with just one person, analyze the results. Then add another person, analyze the results of two, and watch how they change. You add a third person, repeat. And what you'll notice generally, not always, is the difference in the results. Imagine you have two people and the difference in the results is this big. When you add a third person, the results change by this much. And when you add a fourth person, the results change by this much. And the amount of change that new participants adds declines with each participant. So by the time, if you get to 1,000 participants, adding number 1,001 doesn't change the results, might not change the results at all. And then you know, okay, I'm really confident now that I'm finished. That's an extreme example. But that's one way of having some idea of how many people do I need. Any other questions? But you'll talk to your supervisor. And your supervisor will give you their opinion about how many people you need for a study. Yeah. Any other questions? I think we're out of time, so we'll stop here, yeah? Thanks, everybody.